All right, welcome to Notes 3.5. Is it a function and evaluate graphs? So when is it not a function, or when is it a function? When there are no repeating x values on a table or a group of ordered pairs, and the graph passes the vertical line test, meaning an up and down line crosses the graph only once. Okay, so basically, you can't have two x values of the same thing because on a graph, you want an up and down line to only be touching that graph the one time. So your graph can't be overlapping on the top and on the bottom, but it's okay if it's kind of overlapping side to side. So what I mean by that is if you have a graph, this would be considered a function, but this would not, because see how the line overlaps top and bottom? So that's what basically this is all saying. And then we're going to evaluate functions. So on a graph, if you're given an x, you're going to find the y. If you're given a y, you're going to find the x. So you're just looking at the graph to figure it out. The equations, if you're given an x, you're going to solve for y. I haven't decided if I'm going to do the reverse. We'll see. So looking at this first set of ordered pairs, I'm only looking at the x values because that's the ones we don't want repeating. And in this case, we do have repeating x values. We have a repeat of when x equals 1. So that means it is not a function. Okay? Because if I drew a graph here, this point would be at the bottom, this point would be at the top, and see how they are straight up and down overlapping? And I just said that you do not want that because then it is not considered a function. Okay. In our next one here, we got 1, -2, -2, 1. So in this case, we have repeat of x equals -2 and when x equals 1. So this again is not a function. All right. This next one, all right, so this is where we're going to need a vertical line test. So we're going to go straight up and down. So on my graph, it only touches the graph that's drawn here, this guy, once. Let me highlight that. All right, so it's only touching this blue line once, all the way through. So this is considered a function because it passes the VLT, the vertical line test. All right, so our next graph here, we have kind of looks like an M. Okay, so when I do my vertical line test, at first you're probably going to go, yeah, this is great. But look at this line right here. See how it's touching this line repeatedly over and over at this point? This is a value, this is a value, this is a value, this is a value. So this is not a function. All right, because of that, so that means it fails the VLT. So whenever it fails the vertical line test, I want you to show it to me where it fails at, like how we did here. In our next example, right, we got this graph here. We've seen this one a couple of times when we're talking about functions. And this one passes the vertical line test because the whole time, anywhere I'm drawing a line, it is only touching that blue line once. It's passing that vertical line test. So this is a function because it passes the VLT. I have nowhere to show that it does fail. The next one we got is a circle. All right, so at first, right, if you look at this first part right here, this would consider passing until you move just a smidgen over. And then right there, it's touching that circle. My vertical line is touching that circle in two places. So it does not pass. It is not a function because it fails the vertical line test. F for failure for this guy. Okay? So again, as long as your up and down line isn't going to touch your function more than once, it will pass. All right, in this next one, we got a table of values. So we got these guys right here. We are looking for any repeats. We have repeats at the 2's, so this is not a function. If I drew these dots on a graph, it would fail the VLT. Looking at our next one here, we have 12, 3, 4, and 9. There are no repeats, so it is a function. So if I graphed all these points, nobody would be overlapping above and below. All right, then we're going to evaluate using the graph above. I was going to have you guys pick out your own, things here, but I'm going to have to pick today. So when f of -4 equals blank, okay? So usually there's an x value here. So I'm going to find an x value of -4, which is this guy. All I'm going to do is go up to the function right here. Here's at the function of -4. The y value for that is 8. So let me do some colors for you guys. There you go. Let's say I have f of, let's say, 5. Yeah, let's do 5. Equals blank. We have an x value here, so I'm looking for the 5 on the x-axis. Where does it hit the function? It hits the function right here on this blue line of the function. And that y value there is 1. Let's do a reverse. Let's say we have f of x equals 5 when x equals blank. Okay, so in this case, we have the y value. This is what we're trying to figure out. Now, these guys, you got to be careful because here's my 5 on my y-axis. When I go to the function, it hits here at -1. However, it also hits here at -7. Okay, so sometimes you might have more than one x value that works for a y value. So you need to make sure you look all the way across. So let's do another one. We have f of x equals, let's do 2. All right, so this is a y value. This is what we're trying to figure out. So here's my y value. When I go to the function, it hits here at 1. And then I got to check, and it hits, right here at 4. Okay, so you got to make sure you show all of the values. Will y values always have more than one? No, because sometimes maybe the line is just straight up linear. But with functions that are piecewise, like the example above, you may have more than one x value for the y values, so you just need to be conscientious of that fact. When it is a function, though, these guys over here will only have one answer because this is a function. It would pass my vertical line test. There is nobody that is there is no part of the line that is above and below each other like that circle was earlier. All right, I need to be quiet so I can start giving you guys time. All right, so in this one, we have two tables that are occurring. So let's say we have f of x equals 7. Okay, so that means this is a y value when x equals what? Well, here's my y value. So its number partner here is 8. What if I did g? Because we have f and g here. What if I said g of 6 equals blank? Well, this is an x value. So I'm going to look at the g. Here's the x value for 6. Its number partner is -5. Okay. What if I say g of x equals 10 when x equals blank? Well, this friend right here is a y. So we're trying to figure out x. So these are like your y's. Here's my 10. Its number partner is negative 8, and that's the only 10 I see, so we're good. Okay, and then we're going to evaluate functions. So let's say f of x equals 3 plus 2x, and let's say g of x equals 7 minus 2x plus 1. So if I say g of 3 equals what? I'm going to use the g of x equation here, but instead of x, I'm going to replace all my x's with this 3. So when I rewrite this, I got 7 minus 2 times 3 plus 1. And then I just evaluate from here. Then I have 7 minus 2 times 4, which gives me 7 minus 8, which is equal to negative 1. What if I do f of, let's do f of 9, right? So that means that all my x values in my f equation here, I'm going to replace all my x's, I'm going to replace with the number 9. I'm not sure if I said that right. So we got 3 plus 2 times 9. Do my evaluating skills. 3 plus 18 equals 21. So there's that one, okay? Now what happens if you have a negative number? That's okay. It's just a negative. So we have let's say g of negative 2. Yeah, let's do negative 2. Equals, we're going to use the g equation. Instead of an x, though, we're going to replace it with a negative 2 plus 1. So let's start evaluating. This gives me 7 minus 2 times negative 1. This gives me 7 plus 2 because a negative times a negative is positive. And then we get 9. Let's do f with a negative. Let's do negative 3. This gives me 3 plus 2 times negative 3. All right, well, we got 3 minus 6 because a negative times a negative is, a negative times a positive is negative. And this gives me negative 3 as my answer. Oh, look at that. All right, that's all of our notes today. I really hope this video wasn't long. Sorry if it was, but you'll be okay. See you guys tomorrow.